1905 was a great year for physics, and for one man in particular, Albert Einstein. In what became known as his miracle year, Einstein published four revolutionary papers that would soon reshape physics. The first paper predicted that light can act like a particle. That paper, which won him his Nobel Prize, was responsible for kick-starting the quantum revolution. His second paper mathematically proved the existence of atoms, but his third and fourth papers lay down the theory of special relativity, one of Einstein's greatest achievements. Special relativity started out with two postulates and went on to disprove Newtonian mechanics. The first postulate was the fact that the laws of physics are the same for all inertial frames. This meant that for all observers who were either still or moving at constant velocity, all the laws of physics apply. The second postulate, which was inferred directly from the Michelson-Morley experiment, was that the speed of light is always constant. The speed of light is now depicted c. Now Einstein's second postulate was an interesting claim. Einstein claimed that all observers would measure the same speed of light, no matter how they were moving. This contradicted everyday experience. In real life, if two people walk in opposite directions at 1 meter per second, it would seem to each observer that they were still, and the other person was moving away at 2 meters per second. But in the case of light, the observed speed is the same no matter how the observer is moving. Even if the observer is moving away from the light beam at half the speed of light, he would measure the speed of light to be exactly c, rather than 1.5 times as c. Now there was another problem. Newton had established that space was relative and not absolute. But for the speed of light to be absolute and constant, the space moved over the time taken had to be constant. So if space was relative, time also had to be relative. This meant that different people would measure time differently depending on their motion. If, from a pair of twins, one twin went on a high-speed intergalactic journey while the other one stayed on the Earth, the two twins would not age in equal amount. And so, from two postulates, Einstein developed an entire theory that proved Newton wrong. A theory that predicted that your speed affects your concept of time, your mass, and even your size. A theory that marked the beginning of another revolution in physics. A revolution that eventually saw the formulation of general relativity and quantum mechanics.